Hello everyone. Welcome you all to the TechGig webinar. Thank you for joining the session today. The topic of today's talk is Demystifying Security Data Science Part 1. It will be a 1-hour session with around 40 to 45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the questions tab on the GoToWebinar control panel. I'm Sabah, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker today, Mr. Satnam Singh, Chief Data Scientist at Calvio Technologies. Satnam has more than a decade of work experience in successfully building data products from concept to production in multiple domains. Apart from holding a PhD degree in ECE from the University of Connecticut, Satnam also holds a master's in ECE from the University of Wyoming. Satnam is a senior IEEE member and a regular speaker at various big data and data science conferences. So without any further delay, let's begin the session. Over to you, Satnam.
Thank you, Sabah. And thank you, participants, for taking out your valuable time and attending this webinar. I hope this webinar will give you a lot more profound knowledge and introduction to the security data science. So let's get started. So the data breaches and ransomware attacks are not really old news. It is becoming everyday news now. Back in September, Equifax data breach, it was one of the largest data breach in the history. Around 143 million customers, their personal data was available on the dark web. And this data breach was actually detected after 2.5 months. So the attackers were there in Equifax networks for 2.5 months, and they were exfiltrating the data and stealing the data. And this is not really something which is happening just 7 oceans apart from us. It is happening right also in India as well. So this is a picture of an ATM where the ransomware attack happened. And I personally know a lot of small businesses and medium by ransomware called WannaCry, and that was sometime back in May. And the attackers are finding new ways to do more and more attack, and ransomware is a lucrative way for them. In that case, attackers ask for ransom in order to give you the encryption key back. So now let's first understand why these attacks are happening. And then we will get into the security data science, that how security data science will help you to solve this problem. So when we talk about the security controls, back in 90s and 2000, it has been primarily as a perimeter-based control. Now, what do I mean by that? It's like building a fort, right? So you build big walls, and you think that you are safe because the walls are saving you from the thief and the robbers. So in this case, we are building the walls using firewall, intrusion detection system, intrusion prevention system, network intrusion detection system, and so on. But that was okay way back in 90s and 2000. But now users are using a lot more devices. We are using mobile devices. We are using tablets. We have 3 to 4 devices, and we are always connected. And not everywhere we would be logging into VPN and then getting into the enterprise. It will be the corporate VPN used to be only one place, but now this corporate boundary has been broken. That perimeter has been broken. As an attacker can compromise any of the single user or a single system through one of the vulnerability or through one of the phishing attack and then get into the system, and then he does the lateral movement and figures out where are the key assets, and he tries to steal the data. So it could be a human attacker, it could be a malware, ransomware, or a botnet, or different type of attacks. So as I told you, there are different kind of attack vectors, and the perimeter is huge. The defense mechanism is also huge. And this is the cybersecurity landscape. Uh, this is by Momentum Cyberspace report. And you see there are different verticals, and there are like some 200 plus companies which are providing the securities in network, endpoint, application, web security, and mobile security, data security, and so on. And at Atalvio, we are one of the specialized deception company which fuses the deception and the data science together, and we provide advanced threat analysis and advanced security within the perimeter. So let's get into the more nitty-gritty, more details into the security data science. Well, whenever we talk about a data science, first we need to understand what are the data sources. So let's get into the various data sources, use cases, and methods. So one of the key data source is network logs. So let's look at this picture. This picture is a very simple representation of an enterprise network. And typically enterprise networks are like 90 to 95%, they are following the star topology. And endpoints, printers, routers, switches, various security controls like firewalls, IDS, IPS, and so on, they are connected in this star topology. And there is a somewhere demilitarized zone, DMZ, is also there. Now, this is a very simple representation of the enterprise. Now, these network logs in the form of like firewall logs or IDS, IPS alerts or network flows and even DNS logs, they give us new cameras. These cameras have been there from 90s now, but what has happened is, over the time, the data volume has increased a lot, and attackers have come to know about these security mechanisms, and so they have changed and they have adapted themselves to bypass these control mechanisms. But in any ways, with using the data science, we can still find the signals of attackers' presence. And or when I say attacker, means it could be a malware, ransomware, or human. And there are a lot of use cases which can be enabled by analyzing these network logs. So let's look at few use cases. So one of the example is like unusual volume of network activity. So if we watch the network activity and we look at the bytes out and the bytes in for a specific endpoint, and we compute something called producer to consumer ratio, then we can figure out that if that particular host is exfiltrating a data. And there is another use case like there are ports which are typically closed, but if there are ports which are being started in use and their activities over there starts increasing. So something like SMB has been used a lot by WannaCry for doing a lateral movement. So if we start watching the activities across the SMB port, then we can see, okay, yes, why there is a sudden increase more than the baseline, then we can detect that and then we can trigger as an anomaly. So there are other set of data logs like endpoint logs. So endpoints could be various operating systems, could be Mac, could be Windows, which are typically 90 to 95% in most of the enterprises. And then Linux servers are there, and obviously these printers having a different operating systems and different embedded systems as well, and IoT devices as well. These endpoint logs are typically logged by the endpoint monitoring systems. So various antivirus companies, AV tools, they log them, and these logs are also including like system logs, file system changes, applications, processes, operating system logs, sys logs, AV alerts. Now these gives a lot of visibility on the endpoints. The problem is like the endpoints are too many. So in a typical corporation, the endpoints could be more than the 4 times or 3 to 4 times of the number of you can think of, depending on the corporation size, the employee size, the number of endpoints also increases, and the number of servers also increases. So if we need to get all these logs and process them, it's a big data challenge. And then we need to analyze all those anomalies and the alerts. So anyways, let's look at the various use cases which are made possible by analyzing these endpoint logs. So one of the use cases, by observing anomalous new listening port or service or process, we can raise an anomaly. And that gives one pretty good suspicion, because typically the ports or the services are highly controlled by the security team. And if we start observing that certain ports are having activity, then it can indicate a compromised host or a compromised endpoint. And the same thing is, with the excessive number of listening ports and services or processes on a certain endpoint may also indicate anomaly on a specific endpoint. So other set of logs are more from the authentication logs, and Windows events are also one of the important data source here, and they can actually help the defense team to detect the lateral movement. When I say lateral movements, when attacker or the malware is moving from one system to another system in the enterprise to seek for their destination or to seek for their target, because they are after the data or they are after the key users, like domain users, the key administrative users who have the access to the entire domain. And then they want to grab the data and also the key assets of the company. And that's what the attackers are after. So in order to do that, they would be doing some lateral movement, and that lateral movement can be detected by Windows events. Active Directory is one of the key data source. Active Directory by watching Active Directory logs, by looking at the anomalies over there, we can see if the behavior of a particular user is changing from its normal behavior, then that can be raised as an alarm. Privileged user management is another important data source and as well important category for the security data science. And most of them actually falls into the bucket of user behavior analytics. And as I said, it enables a lot of use cases on user behavior analytics. And so we can enable lots of use cases, like we can detect brute force attack, We can watch for default account usage or account activities which were sort of dormant and then they become active. Or sometimes, the employees, those who have left, and their accounts being not frozen, but they have been used. So what I described here was more of a broad categories of these logs. So let's get into a little more hands-on experience of these data sources. So what I will do is I will show these data sources in another screen, which is from Splunk. And so let me show you that. So here I'm showing you the vulnerability data source. Vulnerability data source is one of the important data source. And as I was telling you in the beginning that Equifax data breach, which was one of the largest data breach, their attackers actually leveraged the vulnerability in Apache Struts, which is one of the important and widely used enterprise application software. And there was a data breach, which that data breach was leveraged a vulnerability in Apache sticks. Now, vulnerabilities database is important, and if we start analyzing that, and the security team have to follow a robust process to fix those vulnerabilities. Now, from the security data science perspective, we can see what those vulnerabilities are, what operating systems they are applicable, and in this case, it is just starting with a simple dashboard. So what I'm showing you here is just a Splunk dashboard. Splunk is one of the SIM. When I say SIM, means security information and event management tool. And there are a lot of SIMs out there, and Splunk is one of them. So let's look at, if you want to look at in the vulnerabilities, some of the key fields. So here we want to do, if you look at the vulnerabilities here, the logs are typically, these are the raw logs, and we can't really analyze them. So what we need to do is we need to use SIM like Splunk, which helps us to ingest the data and index it. And after the indexing, we can query it. So in this case, we are querying it using a Splunk query language. And here I have written a Splunk query language where I'm specifying the index vulnerabilities. And I'm doing a stats. Stats command computes the count for various fields. And in this case, the fields, what I'm specifying is destination, CV, and severity. So let's click on that. And what we look at here, it shows the CV number for a specific vulnerability. We can analyze for that. We can also visualize as well if we want to visualize for, let's say, a particular count for a specific destination, then we can visualize that as well. It can be visualized in a various forms. Now, these are the various ways by which security incidents and security analysts typically use a dashboard and also the stats tables to make some decision or to analyze some threat. Now, what we want to do is we want to leverage machine learning, data science to go to the next stage, right? So let's get into that part. So what we do is, in a typical machine learning pipeline, this is how it goes. In the step is the log processing. The logs are typically unstructured data, and we can't really analyze that just in a plain text format. We need to make it into a structured form. And this itself is, I would say, couple of hours talk that how you process logs, because it's a big data processing, and which kind of big data tools are being used. Nowadays, Kafka is one of the prominent ingestion data logging tool, and also it can be combined along with the other open source data sources like ELK, Elasticsearch, Logstash, and Kibana. So we can use Kafka along with ELK or ELK alone for doing the log processing. And there are lots of architectures possible for log processing. It all depends on what's the size of the organization. Is it a small scale, medium scale, large scale? And depending on that, the log volume will be also determined. And then we have to also see what are the end use cases for analyzing the logs. So anyways, in this case, we are leveraging Splunk to ingest the data and index it. And after it has been indexed, we are getting a key value pairs. And once we get the key values, then we can do some sort of summary statistics, and then we can do some data analysis using data science. So the step 2 is doing some kind of summary statistics. So in this case, we are computing the counts. So here we are showing the SSH counts, and a typical use case is like looking at the SSH counts and then see who are the users and what are the top counts, and is it deviating from the normal behavior. So that step 3 comes down to the anomaly detection part, where we want to analyze, is the system is changing with respect to its peers or with respect to its historical behavior. And that's what is being called as anomalies and outliers. In this case, it is being shown that SSH data, that SSH counts is changed for one particular system, drastically changed as compared to its peers. So it is being triggered as an anomalous, and now analyst has to investigate. Now this kind of anomaly detection can be done using machine learning and the data science. Now this falls into a bucket of user behavior analytics, and this also needs a big data framework. We need to ingest the data into some sort of Hadoop, Spark, or some other big data framework, where on the top of that we need to apply some machine learning and the anomaly detection algorithms. So let's look at what are the different anomaly detection methods that can be applied. So if we don't have any labels, which is the typical case in the security domain, then we get into the outlier detection or the unsupervised anomaly detection way. And in that set of methods, we have to use some combination of anomaly detection techniques to first form a baseline, to learn the baseline or so-called a normal behavior of the system, and then raise an alert or raise an alarm when there is a significant deviation from the baseline. Now, in the second set of techniques, which is called semi-supervised anomaly detection, in that case, the training data contains some labels, and we already know that, okay, this one is the normal data, and there are no anomalies inside that. So we can actually leverage that information to do a better job at detecting now anomalies and so-called alerts as well, and raising alerts. And the third set of techniques is the supervised anomaly detection. In this case, we have the labels available, but the anomalies are very few. So it turns out to be an imbalanced classification problem, and we have to use some of the tricks so that we can do a classification properly. There are lots of tricks that can be applied. One of the way could be how you sample the data to do the classification. So a class which has anomalies, which is typically having a very less data, you oversample it, and then the normal class has lots of data, so you undersample it, and then you do the classification. Reservoir sampling is another technique which can be applied, and also in any case, we can also apply more cross validation and doing a proper job using a precision recall and computing the performance metrics to make sure that whatever techniques and the models which we are building, they are robust enough for a production deployment. So let's get into a demo. And in this particular demo, what we will do, we will look at something called a PCR, producer to consumer ratio. And this can indicate an exfiltration attempt or exfiltration by any of the compromised system. So this, in a typical enterprise, has to be done for everything, for every host, for every network device, and so it's a complex problem. And what I'm describing here is for one of the end user, for one of the end machine, how we do it. And I will demonstrate that using 3 different anomaly detection techniques here. So let's look at the web data, which is being typically used for this exfiltration detection. So web data is your HTTP traffic data. So let's look at that traffic data. So what we can do is, let's get back to the Splunk and we look at the web data. So as I said earlier that, if we start looking at the web logs just like that, it's not going to make too much of sense. So we need to specify certain attributes, certain features, which we want to leverage for our analysis. So in this case, we want to look at the bytes in and the bytes out. So I'm looking at one of the endpoint here. Yeah, this one shows for all the endpoints, but we can specify an endpoint as well. So here it shows the bytes in or bytes out, and we can compute the PCR for that. And if we look at the visualization, it's not going to make too much sense because there are too many endpoints over here. So we need to have a much more systematic way of doing the analysis. So what we need to do is we need to capture the data for a specific endpoint and then build the anomaly detection on the top of this. So what we do is we query this data and we do the analysis in a Python notebook. And this is for the demo. And so we have built a Python notebook here where we are doing this exfiltration. So this is just showing that, the various modules which we are leveraging and the various detectors which we are leveraging here. we are preparing the data, training data, test data, and in this case, the training data is sort of, we specified like, this much is the training data and this much is the test data. Now, in a typical production environment, the way it is done is you put the system there for some time, like over a week or something like that, and then it learns the behavior and the normal behavior, and then after that it starts applying the model for the test data, which is on the right side of it. So and then we have to keep updating the model or keep learning the model over the time as well. So let's start analyzing the data here. So what we have done is we have filtered the data for a specific host. So we are doing the analysis for each host wise, and we are interested in this so-called producer to consumer ratio, and it is computed as bytes out minus bytes in divided by the summation of bytes out and bytes in. What basically it is saying that if there is a host or there is an endpoint which is suddenly starting to send a lot more data, which is typically it is more of a consumer, but it becomes a producer. So then it is anomalous. It is anomaly, and then we should raise that anomaly. So this shows a distribution of training data and the test data. And if it starts moving more positive, then it becomes more of a producer. So let's get into the first anomaly detection algorithm. In this case, we are leveraging the DB scan algorithm. So let's get into the DB scan. So the DB scan algorithm is one of the robust anomaly detector. And the way it works is that it makes the clusters on the high dimensional data using the density, and it leverages the minimum number of points and so-called epsilon, which is sort of an indicator of the radius of the density curve or the hyperball. And those are the parameters, and with that, it constructs the clusters, and then it constructs the clusters, and you don't need to specify the number of clusters. This is a typical case in k-means. You need to specify the clusters, but here you don't need to. And the points which are away from the largest cluster, you can typically announce it as an anomaly. So in this case, when we apply DB scan algorithm, this is how it behaves. It detects the anomalies here, and it has flagged these 4 anomalous points here. Now let's look at another algorithm, which is called T-digest algorithm. Now, the reason I picked up T-digest is because the T-digest is one of the key algorithm if you want to apply for a streaming data, and if you want to apply for in the scenario where you have more of a big data, and DB scan typically does not scale that well. So in that scenario, we can leverage T-digest. So T-digest is sort of like one-dimensional k-means, and what you are doing is you are constructing the quantiles and computing the quantiles, and then at the extreme ends, you sample more, you compute more efficiently, and then in the middle parts of your CDF, you sample less. So this calculation or the computation of medians of quantiles is done much more efficiently, and so it is not really taking a lots of computation time, and it can be done in a streaming fashion. So when we leverage this this particular algorithm, then we can also detect the anomalies, and in this case, T-Digest is giving you a lot more anomalies, and depending, it also depends on the thresholds what you are specifying, but that's how because since you are trying to gain more over the computation time, you may end up having it on slightly larger number of anomalies. So let's get into another class of algorithms, which is one-class SVM. And one-class SVM is one of the good anomaly detection algorithm. Again, there are issues of scalability for one-class SVM, but for the scenarios where it has to be done more for a batch process or the more of a batch anomaly detection, this can be done. So one-class SVM is sort of like building a hyperball in a high-dimensional space, and whenever there are the observations which are away from the hyperball, and then those are flagged as anomalies or abnormal. So let's look at the one-class SVM results as well. So this is what it shows for a one-class SVM, and here it shows these are the three anomalies, and these anomalies are also on the PCR values, which are of high values. Now, when we combine these anomaly detections, then we compute something called, when we termed it as an ensemble anomaly detector. What it is doing is it is just doing a majority voting and saying that, okay, if there are two or more detectors, in this case, they agree that this is an anomaly. So, that is flagged as anomaly. So in this case, we finally got three anomalies here. Now, the point is, the security data science or so-called anomaly detection techniques over here, we are able to leverage that, and we are able to detect these anomalies automatically, but we need the security analysts to investigate them further, that why these anomalies are occurring. So in a nutshell, if we summarize it, security data science is helping us to help fight against the machines. When I say, there are machines, those who are emitting the malwares and botnets and the hackers or the attackers who are using those machines, we can use data science, we can leverage the big data free infrastructure and the machines power, computing power to fight against those attacks. And it can find the needle in the haystack, but still, there are some challenges. And the challenge, one of the key challenges, there are too many alerts. And many of them are false positives, and we need to have security analysts to look at. And as a matter of fact, I will tell you that the security analysts are too few. In fact, 1 out of every 4 enterprise is lacking the number of security analysts, and they are at the mercy of attackers, I would say, because they are vulnerable to the security attacks for more than 6 months because of not able to hire security analysts. So by the time, we can't hire that many security analysts, or we can't have that many security data scientists, what we need to do is we need to leverage a different approach. And This approach, we are calling it as a deception-based approach, a deceptive security. This is inspired by nature. So just like in nature, various plants and animals, they leverage the deception as a way to save themselves and also as a way to carry over their life further and to survive and for not to get extincted in the nature. So the way you see this picture here that owl is blended behind a tree, and so the predators they are not able to see the owl, and an owl can take some rest here. This is one of the example, and there are hundreds of such examples in the nature. And another one, I had it on my slide, first slide itself. That was of carnivorous plant, which is actually setting up a trap to eat the insects. So how do we leverage the deception in the enterprise? We can use the deception to deploy lots of decoys, low interaction and high interaction decoys, which are like sort of a fake host and fake databases and fake applications. So when the attacker comes in, he does not know what is real, what is fake, and he bumps onto one of them, then it would trigger an alarm. And this is sort of like putting the landmines all over the network, and then whenever the attacker or malware or human gets bumped onto them, it would trigger an alarm, and that alert is being used further along with the data science to give a lot more rich information and a lot more concrete information which can be used for threat hunting and which can be used for incident response. Now this actually balance out, because the data science was something which was giving lots of alert, and deception is giving very few alerts but with a high fidelity. So we can combine the power of data science and deception together. And this shows one of the use case of the deception and the data science together, where we are leveraging the deception and the data science to find the path what attacker may have taken. So in this case, the red path shows the attacker movement in the enterprise. So there are a lot of other use cases which is enabled by combining this data science along with the security. So with that, I'm reaching the end of my presentation, and I would like to be a little more philosophical here and share sort of my journey of building the data science product with this climbing picture. What I see that building a data science product is something like a climbing over the rocks, because you don't know the route, you have to figure out the route. There is a lot of challenge. There is adventure there. You have to work with others, just like in the climbing, you need to have a partner. So here also, you need to work with a team, and especially, in this case as well, I have a team, who has helped me building these data science product. And at Acalvio, Deepak and Wasim, they helped specifically for some of the use cases which I have shared in this particular presentation. So I would suggest that security data science is an exciting area, and not only security, pick up any domain, combine it along with the data science, and then go for it, and enjoy the journey. And here is a GitHub page which has lots of links to go into the depth of security data science, and I'll open it for the questions. Okay. So I'm looking at the questions. So one of the question I have it from Stephen. Various endpoints and network logs from the use case. What kind of advanced threat report does and type of interactions of user ID, password data, and from where, IP, country, etc. would be visible to report to regulator authority of respective countries. Okay. Okay, what kind of subscription companies can leverage your service offerings? Okay, Stephen. So, Stephen, we are more into the advanced security, and what we do is more within the perimeter, within the enterprise, and uh, what can be also done is at the perimeter as well. So something like Open DNS, what they do is, they will monitor uh, the DNS logs, and then they will say what are the IP addresses, what are the domain names which attackers are leveraging, and that can be automatically kept automatically added in the block list, and they are also shared across with the different threat intelligence feeds, and also from the various security monitoring threat intelligence companies as well. So as such, Calvio is not in that space, and I can take more as an offline question that what a Calvio does. I just want to have this particular talk more of a technical technology talk where I elaborated more on security data science. Yeah, thanks for asking question, Stephen. So Fateh has asked, please name some of the must-have tools and antivirus softwares to prevent security mishaps. So Fateh, there are something like, we say hygiene, okay? So security, as I said, is a multi-layer problem. We need to have security at various layers, and if I name the various layers, this slide actually is will do a proper justice to it, because there are various verticals. We have to think about the network security, endpoint security, web security, security data lake altogether, like secure SIM. So I would not get into specific names, but what I would suggest is that we need to have security on each of these verticals, and then there are a lot of open source tools are also available. We can start from there. So I don't know whether you are in a big enterprise or medium enterprise or a small enterprise, or even an end user. We can do a lot. Being a security conscious person, what we could do is, uh, if I am an end user, I would just start very simple. I would just put an open DNS and start, making sure that I have open DNS, which is looking at my DNS logs, and it is blocking some of those DNS-based attacks, and it is looking at some of the CNCs, and if one of the CNC happen to be in my email, then it will block it. There are lots of other tools which are available. So I would say focus on each layer of security and maintain the basic hygiene as well, that using the two-factor authentication and encrypting the device and having the strong passwords, and those are all basic hygiene have to be maintained. So Sheikh Mahaboob has asked me, other than Splunk, any other tools? Oh yes, there are lots of tools for analyzing the security data sources. Alien Vault is one of the open source SIM. ELK, Elasticsearch, Logstash, Kibana is also the one of the tool. In fact, Splunk is also you can leverage for small data. I mean, beyond certain data, you have to pay for the enterprise usage. And there are other data sources, other SIM as well. So I would say that all these are into a bucket of SIM. And if you look at this particular diagram, there is a one security operations and incident response. This will actually give you a whole bunch of other technology providers who are in that space. So, okay, so one of the question is from Gayatri Devi. I'm sorry if I am not pronouncing your name correctly. Gayatri Devi, your question is, how can machine learning be integrated with data science for threat detection? So I gave you one example of detecting the exfiltration using the web logs, and that was my demo using various anomaly detection techniques. We can detect the exfiltration from the web logs. And I have also shared various use cases from different logs, which we can use machine learning and data science. And they are all for the detection. And they would detect anomalies, and then these anomalies have to be combined and fused to raise further alarm and alert to the analyst, and who has to investigate this. Okay, so all right, so I'm just going to pick up some more questions which are more on the in the context of this particular security data science. So so one of the data sources, what type of data can be used for combining deception with data science? So there are lots of use cases. We can combine all the security events, whatever logs I discussed. Those can be combined with the deception alerts. So this question was asked by Archit, and thanks for asking the question. Okay, so I will take one of the philosophical question here by Yoga Lakshmi Shekhar, and the question is, could you please let us know that what obstacles you faced while starting this journey? So thanks for asking this question. As I said, it's a challenge whenever you start something new, and any of the new use case for data science, you have to understand the domain. And thanks to the internet, we have the open knowledge. We can always go and acquire the knowledge, and the key challenge is applying it. So I think it's just a basic principles that getting up to the domain, understanding the use cases, and for its data science, we need to handle all three things. And number one is, what's the domain, what's the use case, and number two is, we need to understand what's the data volume and variety and so on. So we need to understand and then apply the appropriate infrastructure and build the appropriate infrastructure along with the visualization. So it's not just the algorithm alone. We have to leverage algorithm, visualization, and the infrastructure all together to build a data science product. Okay, so there is a question by Shiv Shankar, and the question is a very interesting question. And how do we identify the false positives? Any mechanisms you suggest apart from the conventional way? So, Shiv Shankar, one of the conventional ways, obviously, you have to call that particular user or get hold of more details of that log and then uh, investigate that whether this is a false alarm or not. So let's take an example of brute force attack, right? If we see a large number of failed authentication or failed login attempts, if it is like, more than 1,000, more than 2,000 from a certain host, then it could indicate that there is some script, which was running, and that is actually triggering an alarm. Now, that is coming more from a knowledge, right? That is coming more from a domain knowledge. So we can incorporate such domain knowledge from incident response playbooks, and by working along with security analysts, and then we can codify that as a graph problem or as an anomaly detection problem or as a supervised machine learning problem, and then we can actually uh, avoid the false alarms. So another way is like, if we use these deceptions, which are so-called a reincarnation of honeypots, we can put these deceptions or honeypots over those endpoints or around those endpoints. And if there is any activity around them, then it would trigger an alarm. So that is another way of detecting uh, a true detection, and then reducing the false positives. Okay, Tushar has asked a very good question. Tushar, your question is, what can we do to save from ransomware attacks? Well, as I said earlier, for any type of attack, we have to maintain the basic security hygiene. And the security hygiene is, security is more of, it's a multi-layer problem, and in an enterprise we have to think about each and every layer. But as an end user, if you are saying, in that case, you have to back up your data, you need to have some kind of a cloud-based backup system as well, so that having an offline backup as well can save you from a ransomware. Along with this, for an enterprise, there are lots of other tools can be used, and in fact, deception is also another one of the one of the powerful technique to detect the ransomwares. And because in the case of ransomware, they change their signatures. You can't detect them with a traditional antivirus. So the AV tools are more effective, after it has been detected. So like, WannaCry case, once it was detected, then, everybody else updated their signatures, and then, it became more of like, okay, you update your AV and then you will be safe. But, at the first time you want to prevent from yourself from ransomware, you have to follow the basic hygiene, all those phishing attacks. You have to follow the basic practices, not clicking them and things like that, and also doing an offline regular backup will save you from the ransomwares. So I'm going to take this as a last question from Surya Bharti. Is data science offers more jobs in IT field? Oh, absolutely. As I said, the security data science is offering, it's opening up a new opportunity altogether for a career. And this is a combination of IT security and data science. And, I would highly recommend to pursue this particular career path as well. But no matter what, we are at the verge of having a lot more attacks, and we are on the, I would say, on the mercy of attackers, because we have lot more peripheral, lot more porous boundaries, and we need to have lot more people working in this area to defend ourselves. And we need new tools, we need new innovations, and new thinking to defend ourselves. So with that, I think I'll stop taking the questions now, and we will again join in part 2. And I appreciate taking your time and attending this webinar. Thank you very much.
Thank you so much, Satnam, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This session has been recorded and the recording will soon be available on techig.com. Thank you everyone for joining us.